One of the things you'll probably want to know how to do is to log into a laboratory computer without actually being physically in that laboratory. There's a setup of one special machine that's connected to a PLC in our laboratory at school that you'll probably need to access quite often. So I'm going to try and show you how to do it. I'm not 100% sure that my computer will allow me, because this is for my computer it's a lot of work. We'll see what happens. Hopefully everything will show up in the video. If you have any questions about this, please feel free to ask. The main page you need is right here, and I've included a link to it because it has all the instructions you need for connecting. The first thing it says is that you've got to be on the Purdue VPN. And there's instructions here in this link. I'm not going to go to it. You can. I do have the VPN software installed on my computer, but I'm not yet connected. So I'm going to tell it that I want to go ahead and connect, and the address right now is webvpn2.purdue.edu. It's the number 2, not spelled out. So I'm going to hit connect first. It says it's contacting. Now when you log in, you have to log in using a boiler key or Duo. I use boiler keys. I'm not sure how Duo works, but I assume you can do it that way. It's two-factor authentication in any case. So it's asking me for my password, so I have to type in my 4 digits, then comma, and then I've already copied and pasted the boiler key number in, so I'll hit OK. Hopefully this will go through. Yeah, it looks like it's OK. So it accepted my password, and now it's establishing the VPN. Now, VPN is just virtual private network, and I don't understand all the details. It doesn't matter. What it means is that the computer is acting as if it is part of the network in the school. So it's like I've taken my laptop into my office and connected it, and it's just as if I'm sitting there. So I've got access to a bunch of drives that I can't connect to from home without going through the VPN, and whatever, it seems to be secure. This is a requirement for contacting the laboratory machines in our school and using them remotely. So it looks like we're connected. We're good to go. And so we can navigate to the page. There's a link here. I've included a link as well in the description next to this video, and then follow the instructions in the top section of the remote availability site in the above link. So we're going to go here. This is where you actually go to log into a machine. Now this is a little different because here you have to log in not with your boiler key, but as if you were sitting at a lab machine. Now we're not logging into a lab machine yet, but that's the password we need. So I've got mine memorized, I hope. Let's see. Yeah, so it looks like I'm in, and now that I'm in, I can select what lab I want to connect to. Now you can connect to labs on main campus or other sites, but that's not really very useful to you. Now I have to remember how I found what I wanted. I think I knew the lab machine name, but if I didn't, let's see if we can figure this out quickly. PPI should be the Purdue Polytechnic Institute. SOET, School of Engineering Technology, that's us. MSEE is a building on main campus, so is Noy, so is Potter, which is POT. A&D would be Anderson, COL would be Columbus, KOK would be Kokomo, and we are New Albany, NA. Here we are. So we've got labs, Purdue Polytechnic Institute, Statewide Technology, New Albany, and our lab where we're running this class is NA 1136, so that's the one I'm going to select. Within that lab, this is all the machines that are available. Now the special machine is the instructor station, which is the 00 station. Now I don't remember if I had to install something else or what, but I set it up so that I could just click on this link and it would allow me to log in. Now I think I had to install an application. I don't remember what it was, but it came up and guided me through it, so that wasn't a big deal. So I'm going to open it, and so now what it's doing is it's connecting to that machine remotely. I hope that machine is on and up and ready to go. Looks like it is. So now it's asking me to log in to that machine. Now I think that I have to I don't think this will work if I just type my password here as if I'm sitting at the machine. I think it'll come back with an error. Yeah, it doesn't seem too happy. It's going too slow. Well, no, maybe that's okay. I was thinking that what I had to do was type boiler add /dsysc, And you may or may not have to do that. Like I said, I've already done this once and I've forgotten some of the steps. That page that I showed you initially, though, has all the directions you need. It has all the details. Okay, so we're logging into the computer, it looks like. Yeah, it's logging me in. So this is a remote session to that machine. It's as if I'm sitting in front of that machine. All my mouse clicks, my keyboard keystrokes are being sent to that machine, and the video from that machine is being sent back over the internet to me. So right now I'm just logging into a lab machine. Now sometimes this can take a little bit of time. Sometimes it's pretty quick. It's, you know, as if you're sitting there logging in. You know how it goes. Now you don't have to log into the instructor station. The instructor station is an important machine, and I'll show you why that is in just a moment. You can log into any of the computers there. So now I'm operating on the machine in my account, logged in. There are two main programs you will be interested in. There's the program for programming the PLCs, which are the controllers. That's what we're trying to learn how to program. And then there is a program that simulates a manufacturing system. I'll show you both. Let's see, the message of the day came up. I'll close it. The first program you're interested in is the Click Koyo software. I've had it installed in all of the machines in the lab. And when you type Click, there's two options. There's the programming software version 2.6 and there's the project loader version 2.6. We want the programming software. So click that one, and I'm running this software remotely. Now I can connect to a PLC because what I've done, the reason the instructor station is special is because I have a special PLC connected to that machine. And so you can actually connect to the PLC. You'll notice that it's actually connected via Ethernet. So it's not as, honestly, the PLC is not really connected to that machine. It's connected to Ethernet, but that machine already has all of this information, like the IP address and the subnet and all of these things, so that the instructor station is set up to talk to that PLC. Now you could, in theory, log into any machine in that room, and I guess if you knew how, you could talk to this PLC even from your home computer. I don't know how that would work. I think you have to be on the same subnet mask. But anyway, you can certainly log into the instructor station, and I think most of the, or all of the machines one at a time, and still talk to that same PLC as long as you have this information, the IP address, the subnet mask, and then it'll pick it up. You just have to tell it that the network adapter, well, the port type, first of all, is Ethernet instead of USB or serial, and then the Ethernet connection port is you know, the one you want. Now, we're running this class not only in New Albany but also in Anderson. And in fact, at this point, I have more students in Anderson than I have in New Albany. The Anderson site will be up and running soon. We're waiting for PLCs to come in there, so I don't have the IP address of those machines. Another difference in Anderson is that there will be multiples of these PLCs. I had to order new PLCs there anyway, so I just ordered one for each station. So we should have plenty of PLCs to go around. In New Albany, since we already have some Click Koyos that are not Ethernet based, those are the ones that I will let you guys use and practice your programs on. Then you'll save your programs, upload them on the instructor's machine to the big PLC, the main PLC, and then try it out there. So anyway, I want to connect to this PLC, so I'll hit connect, read the project from the PLC. That's fine, it doesn't really matter. I've been playing around with this quite a bit and you know, working with it and making some things. So now this software, this Click programming software, I can put in whatever instructions I want. I can make a program here, a ladder logic program, and I can actually download it to the PLC and make it run by the write project into PLC. So if I made some changes, I added some commands from the command palette over here and did some programming, I could write that new program into the PLC by hitting write project into PLC, because this software is talking to that PLC. Now where things get confusing is that we don't have space in the lab to have a whole manufacturing line. And it'd be nice to have multiple different types of manufacturing lines, because depending on what you need to do, the way you program it may vary a little bit. And I want you to be able to apply your programming techniques to many different types of systems. So number one, I don't have space in the lab for multiple different huge, manufacturing processes. Number two, I don't have the money to buy them. Number three, I don't have enough money to buy or space to have multiple copies of these for all of you. So what we have instead is something called Factory I/O, and if you just search for Factory I/O, you will find it. Now, Factory I/O is not installed on all the computers, and this is true for both Anderson and New Albany. It is only installed on the Instructor station in New Albany, and I don't know where it's going to be installed in Anderson yet. I think on the Instructor station in that room as well. But we'll find out more details on that later. So let's start Factory I/O, and you can see what it is. So we've got two things running on this computer now. One is the Click programming software for programming the external PLC, and then that external PLC will still be able to talk back to this computer and control the process on screen that Factory I/O simulates. Let me show you some of them. They call them scenes. And so there's many different scenes. Let's just open a simple one from A to B. This is really neat because you can actually build a whole environment here, a different process here to be programmed and controlled. Now, I don't expect you guys to do that. That's not part of this class. I will build all of the scenes or the simulators, and you will have to write PLC programs to control these scenes. So instead of having this set out in the lab where you connect the real PLC to all the sensors and you wire it up and there's all the detail of the wiring as well, instead of that, all you will have to do is the programming. Now, wiring is part of the course, but we'll get into that a little bit later. The wiring and the programming I like to separate so that you can learn it a little bit at a time. So if we do things right, we should be able to program this. The sensor down here at the end will respond and give information back to the PLC. There's a motor under here we can turn on. In fact, I may, let's see, orbit camera, there we are. So I should be able to move this around, and yet I'm not able to. I didn't mean to move the conveyor. You should be able to orbit around this. I think my mouse is just not working right. I had an external mouse that I hooked up and it worked fine. So anyway, you should be able to rotate around. You can look at this and see this little conveyor motor under here that the PLC can turn on and off. Now, it's not a virtual PLC, it's the real PLC sitting there. Right now it's sitting on the floor in that lab, and what it will do is send a command to this software, if you program it right, to turn on that motor, and you'll see this tote start moving down the line. Now, this program simulates some physics as well. You can grab a hold of this and move it off, and then when you hit play and you start simulating it, it falls to the floor. As a matter of fact, we can reset this. Let's see, let's stop, and let's pull it back over here onto the conveyor. In fact, let's just partially put it on. Let's do something like this. Let's let it hang precariously off the edge, okay? And now if we hit play, well, that didn't quite do what I wanted. I guess it's not precarious enough. Let me move it out a little farther. There we go. Now if we hit play, it simulates that the tote would fall to the floor. Okay, so this is not, obviously it's not the real system. However, this is a good simulation of real systems that cost a whole lot less than the real thing. They don't take up as much space, and we can all share these and use them. So we only have one copy of Factory I/O at each location, Anderson and New Albany. But that should be adequate. It's as if you have to share the conveyor in the lab. But the nice thing is, this is not the only scene or the only simulator. If we go to scenes, there are some very complicated simulators. Let's discard the changes I made to the other one. So here's an elevator system where you have multiple sensors, multiple motors, so multiple things to sense that the PLC has to sense, and multiple outputs. There are lights here, there are motors, there are many different things where you have to accomplish a task here. Now, I'm not going to show you how to do that right now. That'll be detailed in the course later. And again, I don't really expect you to use this palette over here. That is just for creating and modifying these scenes. In fact, we don't need to see that. I think I can turn that off there. Yeah, there we go. One area you do need to know about, however, is in the, let's see, let me find it. Yeah, here, where it says, let's see, Dock All Tags. That is a really important menu under View. The Dock All Tags gives you a list of all of the inputs and outputs associated with the simulator. So if you do log on to the machine in Anderson or in New Albany, please try this out. Open up one of the scenes and see if you can view all of the inputs and outputs associated with that particular system or scene, because the PLC will have to talk to all of these things. For example, there's an emergency stop button here. That emergency stop needs to be responded to by the PLC. Every one of these things need to be interfaced to the PLC in order to operate properly. What you'll notice is that these brown or orange circle dot things, those are all inputs. In other words, those are sensors. Those are things that will provide sensory data from the system to the PLC. And all of the other types, these green types, are outputs from the PLC. They are actuators. They are things in the system that can be controlled by the PLC. So not surprisingly, we have some lights here. There's light stack B, which has a green, red, and yellow lamp. Now I don't know where that's at. I don't know if you can see it either with the resolution we have on the screen, but there's a light stack here, there's a light stack here, and there's a light stack down here. There's at least 3 that I see right off. And that would make sense because I would expect to see in the list light stack A, B, and C. I see both B and C. Let's see if we can find A. Let's see. Well, it would be one of these green things. Well, they didn't label it consistently. They've got green 0, red 0, and I thought I saw yellow 0 in here somewhere. So I guess the light stacks are not necessarily consistent, but that's okay. There are other things to control as well. Conveyor 0 motor, conveyor 1 motor, conveyor 2 motor. Now, don't worry about this yet. Don't panic. We're going to start slow and we'll work our way up to this. And you'll understand more about what we're looking at here. I just wanted to show you this so that you see we've got all these nice systems that we're going to learn how to program and control. There are a few I would like to have that are not included in this, but this is new for this semester. I'm pretty excited about it. I really enjoyed working with this. Now, there's something else. Let's see. Let me find it again. Let's go back into scenes. Let's see. Let's just open up another scene. There's a little bit of variety. For example, there's a tank here that we can fill. And this is a little bit different if we go to View and then Dock All Tags. It's different because, well, this doesn't have it. Let me try another scene. I know it's the tank scene. Here we go, level control. This is a little bit different because if you notice in the tags, which correspond to all the inputs and outputs the system has, there are some continuous sliders, things that aren't just on or off, but that can take on multiple values. We will talk about analog control a little bit in this class as well, and this is about the only real, well, no, there's a couple of analog simulators they've got, but this is the biggest one, if you will. So you'll notice that there's not just on-off inputs and outputs, there are also continuous inputs and outputs that we can interface to the PLC and do things with. Now I'm looking for something. It's been maybe a week or two since I've dealt with this. Here we are. So if we go to File and then Drivers, this is also another really important part, because this is where we set it up so that Factory I/O can talk to the PLC. Right now the two are not talking, they're not connected. What we're using is something called Modbus. Modbus is a standard way of PLCs communicating, in this case over Ethernet, over TCP/IP. Now you've got an option between TCP/IP client and TCP/IP server. Choose the client here, and I've already got it set up so that it's talking to the correct server. The PLC acts as a server. But if you don't have this, if that doesn't come up, you'll probably have to hit Configuration. In Configuration, you have to type in the correct host number. Now, in New Albany, as I said, that machine is already set up. And by the way, those of you in Anderson, you can remotely connect to the machine in New Albany as well and run Factory I/O there, or you could connect to the one in Anderson. And New Albany students, once we find out what the IP address and everything is and where Factory I/O is installed, you can connect to the machine in Anderson if you want to. But I would just recommend connecting to the machine locally. So anyway, you don't want auto connect on. The correct port is 502 for New Albany. I think it'll be the same for Anderson. I don't know what the IP address will be, but once we get it set up, these are things you really shouldn't have to change. However, you will potentially have to change some settings down here on the digital inputs and digital outputs, offset and count. Now there's more detail to that I want to explain in another video. Right now I'm just trying to give you an overview and not get too bogged down in the nitty-gritty details. But you'll notice once everything's set up, you can hit connect and it will connect to the PLC. You can tell it's connected because it's got a green check mark, and it usually connects pretty quickly. But there are multiple inputs, okay, on the PLC. These are all discrete inputs, and multiple outputs that go to the process. Now, in Factory I/O, it's a little bit confusing because over on the input side it says coils, as if these input buttons are triggering coils in the PLC, whereas it's got inputs on the other side that are really outputs from the PLC going into the process. So it's kind of like the terminology is backward from what you would expect. But again, don't worry about that if you don't understand it. I know some students come into the class with some PLC knowledge, so that's why I'm going into a little more detail here and there. But we have continuous variables down here in blue and continuous variables in blue and brown over here. Why they're blue and brown, again, I'll describe these things later. So now let's go back, and that's pretty much what I wanted to show you. We are actually connected to the PLC. Let me open a different scene. I've actually created some scenes, and I didn't really change anything. I took the default scenes and set up the configuration, and I plan to do this. I have more configurations to make, obviously, but I'm trying to get everything set up so that all you have to do is go into the driver and say connect to the PLC and you're done. You don't have to worry about IP addresses and all those things, but I'm not that far along yet. I should be soon. But let's just choose a simple one. A to B, say set and reset. I'll discard my changes. So let's see, which one is this? I was talking too much while I opened this. A to B, set and reset. There we go. Okay. So now here's the scene, and I think the way I programmed this was for it to go along, trigger the first switch, go, and then trigger the second and stop, and then I don't remember if I had it come back or not. The conveyor motor is just one output, so I think probably what I did was had it go in, be detected here, and just stop once it got to the end. But the program for controlling this is not yet downloaded to the PLC. The PLC is certainly talking to Factory I/O. In fact, I can monitor, view status monitor, and see what all is going on. But this program is not adequate for actually controlling this system in Factory I/O. Now, let me see if I hit File, Open Project. I've already got this saved in Factory I/O development. This is in my own personal account, so when you log onto the machine, you won't have this available. And I'll have to figure out how to make sure you have all the scenes available too, but I think they'll be saved on the machine, on the lab computer. Anyway, from A to B with Modbus, or A to B set and reset. I think set reset is the program I want. So I'll hit open. It's a slightly different program. This is a timer here. There's some other stuff. Now I'm going to send this program to the PLC. This is not the program that is in the physical PLC until I hit write the project into the PLC. Now, by default, runtime edit is checked. I would uncheck that if I were you, if it hasn't already been unchecked. You see, the PLC can remain in run mode and you download a new program to it. I would not recommend that ever. So I uncheck that and I hit OK, and it says, okay, right now the PLC is running. Do you want it to stop? Now on the front of the PLC there is a switch to change from start or from run and stop mode. You can also do that in software. Now the software does not override the hardware setting on the front of the PLC. So right now on that physical PLC in New Albany, the switch is in run mode, but I'm going to change the PLC to stop mode in software by hitting yes. So you notice up here the PLC is stopped. the transfer is complete. In other words, this program in the software is now copied over into the PLC, and it says, okay, right now the PLC is not running. Do you want it to start evaluating this ladder logic and setting the outputs in accordance with its logic? And so I'll say, yes, do that. Go to run mode. So now the PLC is running. Since I'm monitoring, you can see the status of the various timers, sensors, so forth. You can see that the timer is running without any limits on it. So now let's see, let's hit run and see what happens. So sure enough, the PLC turned on this first motor. It's moving the tote along, and hopefully it stops once it gets to the end. I think that's what it's supposed to do. There we go. It stopped. So it shut off the motor. It just simply set a variable, basically, once it detected that there was something here, and then reset that variable once this has reached the end. If we look at the program that I wrote, it's not a perfect program for this situation, but you can see that the first sensor is, let's see, first sensor triggered was what I wrote to set a memory address so that I could note that the first sensor, which is right here at the center line, had been triggered. I could remember that basically, and then later on shut off the conveyor once the second trigger had been censored. Don't worry too much about the details of the program. The point is that program that I showed you right here is the program that's running on a physical PLC, and that physical PLC is controlling a machine, albeit a simulated machine back here on the same computer in Factory I/O. Now, in theory, you could connect to the PLC with two different computers. One running the click programming software where you're monitoring the PLC and seeing what it's doing, and another computer that's also talking to the PLC but running Factory I/O. And that may be a better way to do it, I don't know, but you'll have to know all the details of the IP address and all that. I just thought it was best to put it all on the Instructor station in New Albany, probably the Instructor station in Anderson. Alright, well, I've talked a lot. I hope that my camera recording software was able to pick up this system that's now shown on my screen that's covering up my usual desktop. I'm just going to close Factory I/O. I'm going to close down the click programming software, and in order to exit you need to log out. So if you hit start, just if you were in the machine, you can choose to sign out, and it's signing out, and it'll actually come back to the login screen. To get out of all this, I'll show you what happens. So in a second we'll be to the login screen for that lab machine. Well, no, I'm wrong. It went ahead and kicked me out. It sensed that I had logged off. Now you have to close the window, the terminal window over here as well once you're done. But then we're back where we started, and hopefully now you've gotten a taste of what we're doing. We're programming a real hardware PLC that's actually sitting in the lab, but we're letting that PLC control a simulated factory system. In fact, we have multiple factory systems that we can simulate. I'm pretty excited about this. This is the first semester using this software. The software I used to use is not compatible with Windows 10. We simply couldn't get it to work, and so I've had to transition to the software, but I think it's going to be a very good change. Really looking forward to it, and I want to see what you think of it. I know it's a little confusing at first. Feel free to get with me and talk to me about it to try to understand it better. Feel free, if you're cleared to go on campus, feel free to go into campus, have a look at it, see what it looks like, and physically log on to the actual machine, and hopefully it'll make a little more sense that way.